What's going on, everybody? Welcome back to my YouTube channel. Let's solve this math question, which says find the values of x for which x dot x dot x minus x dot x is equal to 100. Well, in mathematics, dot also means multiplication. So that means x times x times x gives x cubed minus x times x is x squared, and this is equal to 100. Now, our next step will be for us to split 100 into a perfect cube and a perfect square. So 100 into a perfect cube and a perfect square is 125 is a perfect cube minus 25 is a perfect square. So 125 minus 25 gives 100. So we're going to be replacing that here. So we have x cubed minus x squared to be equal to, so instead of writing 100, I'll write 125 minus 25. Now our next step will be for us to move 125 to the left hand side and also move negative 25 to the left hand side. So we have x cubed minus x squared. Now, as 125 crosses to the left, it becomes negative 125. And as negative 25 crosses to the left, it becomes positive 25. Very good. And this is equal to 0 on the right hand side. Now, this simplifies into x cubed minus x squared minus, this is a perfect cube, which means it can be written as 5 cubed plus, and then this is a perfect squared, which means it can be written as 5 squared, and this is equal to 0. Now, our next step will be for us to group. I'm going to be grouping the cubes together. So, grouping the cubes, I have x cubed minus 5 cubed, so minus 5 cubed. And then grouping the square together, we have minus x squared and then plus 5 squared plus 5 squared. This is equal to 0. Well, I'm going to be putting this inside of a bracket. So we have x cubed minus 5 cubed minus, like I said, putting this inside of a bracket. So we open up a bracket, x squared. And now minus times plus gives minus, and then 5 squared. Very good. Equal to 0. So we have two properties here. We have the difference of two cubes, and we also have the difference of two squares. So for properties of difference of two cubes, for example, when I have a cube minus b cube, this is the same as a minus b times a squared plus ab plus b squared. So this is a property of difference of two cubes. And then for the one of difference of two squares, maybe I have a squared minus b squared. This is the same as a minus b times a plus b. So let's apply this one after the other. So for the difference of two cubes, we're writing it like this, in this form. It becomes x minus 5 times x squared plus 5x and then plus 5 squared. Very good. Minus. Now for difference of two squares, writing it in this form, we have x minus 5 times x plus 5. Very good. And this is equal to 0. And now simplifying further, we have x minus 5 times x squared plus 5x, and then plus 5 squared is 25, and then minus x minus 5 times x plus 5. And this is equal to 0. Very good. Now notice that x minus 5 is common, so we can easily factor out x minus 5. And then open up a bracket. So x minus 5 times x squared plus 5x plus 25 divided by x minus 5. I'm going to have this, which is x squared plus 5x plus 25, and then minus x minus 5 times x plus 5 divided by x minus 5. I'm going to have x plus 5. So this is x plus 5. Very good. And this is equal to 0. And now simplifying further, we have x minus 5 times, this is x squared plus 5x plus 25. And then using this negative to open up the bracket, we have negative x, and then negative times positive gives negative 5. And this is equal to 0. Now simplifying what we have inside of this bracket, we have x minus 5 times, this is x squared, and then 5x minus x is plus 4x, and then 25 minus 5 is 20, so plus 20. And this is equal to 0. So we have two cases here. The first case is x minus 5 equal to 0. And then the second case is x squared plus 4x plus 20 equal to 0. So let's solve these cases one after the other. So for the first case, so let's call this case 1. This is where we have x minus 5 to be 0. So getting the first root of x will be, when I move negative 5 to the right hand side, it becomes positive 5. So this is one of the roots of x. Now let's get other roots solving the second case. So for the second case, so let's call this case 2. I have x squared plus 4x plus 20 to be equal to 0. I'm going to be using the quadratic formula to solve this. So using the quadratic formula, a is the coefficient of x squared, and that's 1. B is the coefficient of x, and that's 4. And C is a constant term, 20. Now the quadratic formula we're using, since we are looking for x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's substitute into this quadratic formula. So we have x to be negative b, so negative b is 4 plus or minus the square root of b squared, that is 4 squared, minus 4 times a times c, so 4 times a is 1, times c is 20, all over 2 times a, that's 2 times 1. So simplifying further, we have x to be negative 4 plus or minus the square root of 4 squared is 16 minus 4 times 1 times 20 is 80, all over 2 times 1 is 2. And then this gives x to be negative 4 plus or minus the square root of 16 minus 80, I have negative 64 all over 2. And now simplifying this negative 64 inside of this square root, we have x to be negative 4 plus or minus square root of negative 64 is same as 64 times negative 1 all over 2. And then this simplifies into negative 4 plus or minus. Now we're going to be separating this. Separating, we have the square root of 64 times the square root of negative 1 all over 2. And then we have x to be negative 4 plus or minus the square root of 64 is 8. And the square root of negative 1 is iota, so that's I all over 2. Now notice that from the numerator, 4 is common. So we're going to be factoring out 4. So x will be factor out 4, open bracket, negative 4 divided by 4. I'm going to have negative 1 plus or minus 8i divided by 4. I have 2i all over 2. And now notice that 4 divided by 2 is 2. 2 divided by 2 is 1. So we have x to be 2 times negative 1 plus or minus 2i. So this is an answer, but there are two answers here. So let's separate them. So we have our second root of x to be 2 times negative 1. So let's go with a positive plus 2i. And then the third root of x will be 2 times negative 1. Now this time, go with the negative minus 2i. So we have one real root and two complex roots of x. Very good. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.